Hello everyone, welcome back to our channel. So today we are going to see about the topic cross validation, which is a part of machine learning. It is a very important to know about this topic, and it is a part of advanced machine learning techniques in the part of the syllabus MSc statistics. It is for both pure and applied statistics. Now, before going to the topic cross validation, let us understand why we need cross validation. And if you have seen the coding part, once we have built the model, we have the data set, you have cleaned the data, and you are ready for fitting the model. For example, if you want to fit a linear regression model, let us consider you want to fit linear regression model. Then before fitting the model, you will divide the whole data set into training and testing, right? Which is nothing but you will split the whole data set into training and testing. How you are going to do this? It is by using train underscore test underscore split, right? This is what you are going to use. But what it does actually is, when you split the whole data set into training and testing using train test split, it actually splits the data randomly. And whenever you give, if you have seen in a coding part, there will be a code like random underscore seed. In order to split the whole data set into training and testing, you use the random seed that is equal to 42 or 7, whatever it may be, 100, something else a number. It is a number. And according to this number, it will split the data randomly into the training bucket and the testing bucket. What happens is actually is you splitted the data into training and testing using the random seed 42. Let us consider. Then here it is the training data and it is the testing data, and you have fit the model and you have calculate the accuracy. Let us consider the accuracy is 75%. And when you change this random seed from 42 to 7, then again the training testing data will not be same. It again changes the training data and the testing data. You will get new training data, new train data, and new test data. And when you fit the model into this new train data and new test data, and if you calculate the accuracy, this accuracy, let us consider, it is 80%. This is how the accuracy fluctuates whenever you change this random seed. What is happening here actually? Whenever you are changing the random seed, you are getting a different types of accuracy. There is a fluctuations or variations in the accuracy. Then how do you know that our model is performing better on the testing data? So this is a problem with the train test and split. In order to get rid of this train test split, we use the cross validation. And in this cross validation, we have the 4 types. The first method is leave one out cross validation. Leave one out cross validation. As the name suggests, leave one out cross validation, which is nothing but leave one observation among all of the observations, which is like, if we have 5 data points or 5 records, let us consider 5 records. Let it be 5 records are this one: 1, 2, 3, 4 and 5. This is 1, 2, 3, 4 and 5. These are the 5 records you have. It is leave one out condition, which is nothing but we need to leave this one condition for the testing and this whole for the training. And then next, here we have 5 records. Then we need to repeat this cross validation technique 5 times, which is nothing but at the next time what you do is, this is 1, this is 2, 3, 4 and 5. Now you take this second record has the test data and this first 3, 4, 5 has training data. And you will calculate the accuracy. This is how you need to repeat for the 5 iteration as you has the 5 records. Here what is happening? Based on one prediction, can you say our model is performing well? No, right? It is not correct. This is one disadvantage. And here I have taken just to explain you 5 records. But what if there are thousands, 10,000, 1 lakh? What if a data set has huge number of records? Then we need to repeat that many times, which is nothing but the time consuming, right? Time consuming, and this method becomes so complex, right? And based on one predicted value, we cannot say that our model is predicting good. Our model is generalized model. So this is what the disadvantage of the leave and out cross validation. Okay. And now let us take the next method. So as we have the disadvantages in the first method, we are going to the second method, which is nothing but leave P out cross validation. Leave P out cross validation. Here we have leave 1 out, but here we need to leave P out. For example, let us consider there are n records, and from this n records, take the P value as 2, or let us consider 3. Then this P records, from those n records, this P records will be for the testing and this n records will be for the training. Okay, this is what the leave P out cross validation. So now let us consider there are 10 observations. Okay, 10 observations, and let us consider P has 2 first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This P is equals to 2. It randomly selects. It randomly selects the 2 records from these 10 records. Okay. For has to explain you better, I am taking the first and second value for the testing. Okay. And this all for the training. And again you calculate the accuracy. And then as you change the P value from 2 to 3, 4, 5, 6, this goes on and you calculate the accuracy. But how do you know which P value is the optimal one? Right? We have to run the number of combinations of the P values or number of P values to identify which P value is the optimal one. Right? This is also time consuming. So this is the disadvantage of leave P out cross validation, which is the same case as leave 1 out cross validation. Then the third method comes to fill up this disadvantage, that is K-fold cross validation. Third one is K-fold cross validation. Let us consider the K value has 5 or 4, 5 or 10. Okay. Then you have a total records has 1000. Let us consider. These are the total records. and you need to make the 5 folds. 1 fold, 2 fold, 3 fold, 4 fold and 5 folds. Okay, this is the fold 1. 1, 2, 3, 4. This is the second fold. And this is the third fold. 1, 2, 3, 4, 5. This is the fourth fold. 1, 2, 3, 4, 5. And this is the fifth fold. 1, 2, 3, 4, 5. And you have the 1000 records, and 1000 records divided by 5 folds, which is nothing but 200. In each fold, the records are need to be included 200. Therefore, 200 here, 200, 200, 200 and 200. 200 into 5, which is equals to 1000. And what happens here is, when we are doing the K-fold cross validation, in the first iteration, as there are k is equals to 5, we need to repeat for the 5 iterations. In the first fold, this first data set, first 200 data set will go for the testing data, and this remaining 800 will go for the training data. And in the next one, the second 200, the next 200 observations will go for the testing, and this remaining will go for the training. In the third iteration, this third one will go for the training and remaining for the testing. And in the fourth fold, this fourth 1, 2, 3, 4, 5, sorry. The fourth fold will go for the testing. And in the fifth one, the fifth fold will go for the testing and remaining will go for the training. Then what is the problem in this K-fold cross validation is, whenever let us here we have the first 200, in the second fold second, but what if this test data set contains only the, let us consider our data set is of a binary one, that is 1 and 0, or yes or no, let us consider. And if the test data only contains the observations that has the S values of outcome Y. Okay, if the outcome is yes, if it contains only yes outcome data in this 200, and the training data is of no. Okay, here the data is trained on only no's. Then how can a model can predict on unseen data, which it does not has been trained yet? So it is unable to capture the underlying patterns, which is nothing but the low bias. And in the second fold also, if the second fold only contains one side of the data set, then how it will predict the yes or no? This is the problem. Have you understood the K-fold cross validation? I will explain it once again. For example, let us consider a small example. Your teacher said that you are going to write an exam tomorrow from unit 1 and 2. Let us consider. You are going to have a test unit 1 and 2, and you have learnt unit 1 and 2 totally. But what if in the examination paper the questions are from unit 3? Are you able to answer these questions? No, right? You will say that it is out of the syllabus. Or you will say, ma'am, you didn't say that you will keep the questions from the unit 3. This is the same way as the in the machine also. In the same case of model also. So this is the disadvantage. There is an imbalance between the data set of two sides, which is like yes and no. There should be a balance between two sides of the data set, the positive and the negative, so that if there is a balance between the training data and the testing data, so the model can able to identify which observations or which type of pattern becomes the S, or which type of patterns indicates no. It can able to identify the differences, variations. So this is the advantage of K-fold cross-validation. Now let us consider to resolve this disadvantage. We have the another type. This is the third one, and we have the fourth type, that is stratified K-fold cross-validation. Stratified K-fold cross-validation. In this, what happens is, let us consider K is equals to 5 has the same, which means 1, 2, 3, 4, 5. Okay, 200, 200, 200, 200 and 200. Okay. In the same way, you have the 5 folds. What it does is, in the stratified K-fold cross-validation, it equally divides the data set of ones and zeros to exist in training and testing, which is nothing but there is an equal proportion of yes and no's in the training data set and in the testing data set. So that if there is an equal proportion of ones and zeros in testing and training data set, it can able to identify easily or accurately about the ones and twos. This is how the K-fold cross-validation disadvantage is fulfilled by the stratified K-fold cross-validation. The only thing you need to remember about the difference between the K-fold and the stratified K-fold is equal proportion of ones and twos, ones and zeros in the testing data and the training data. And this is about the cross validation, and I hope you have understood this video. And the one more thing that is left is how do you know the accuracy? For the first fold you calculate the accuracy, and for the second also you calculate the accuracy. For third, for fourth and 5 folds you calculate the accuracy, and you take the average of all these accuracy, and you will say that the average accuracy of the model is 70%. Or you can say the minimum value, the minimum accuracy you get is nothing but the minimum accuracy of this 5 folds, and the maximum accuracy of the model is nothing but the maximum accuracy in this 5 folds. Okay, and that's it for today. And in the next video we are going to learn about the frequent pattern growth algorithm. Thank you everyone. If you like the video, please do like, comment and subscribe to my channel. Thank you everyone. Happy learning to you.